what we did yesterday. We just multiplied, just straight across the top, straight across the bottom. If you divide two fractions, here's what I wrote. Dividing by a fraction is the same as multiplying by its reciprocal. A reciprocal of a fraction. So, like if I had, just as an example, let's say I had 1/4, its reciprocal, you just literally flip it over. That would be 4/1. So, the best way I have ever learned to remember this, they call it keep, change, flip. And if you're dividing fractions is the easiest thing. If you can remember that little statement, that will help you so much. So just have a little practice question. So what that means, I'm going to take 2/7, divide that by 4/5. So to write this so we can do it a little easier, we're just going to keep the 2/7 exactly the same. You change the division sign to multiplication. And then I'm just going to flip over to get the reciprocal for 4/5. So it'd be 5/4. When you're multiplying then, you just straight across the top, straight across the bottom. So 2 times 5 on the top would be 10. 7 times 4 on the bottom would be 28. And then if you can reduce it, you're totally allowed to do that. And you can use your calculator. You could do it by hand. Both those guys are divisible by 2. So that would reduce to 5/14. Some of the questions you might have to reduce a little bit. A lot of them maybe not so much. We'll be crossing stuff out like we did yesterday. Okay. Now, here's the deal with the restrictions. It's the same as yesterday. You can't divide by 0. So the denominator cannot be equal to 0. We'd have to exclude any number that would make that happen. Now, this is a little bit different than yesterday. So we'll have basically what you would have. You'd have your first fraction divided by your second fraction. All right? I don't have any variables in that little example. The deal with the restrictions, the first fraction, you would just have to worry about the denominator, anything that would make the denominator 0. The second fraction, if you're working with a division problem, gets flipped over. So it's at any point in the problem if something's in the denominator. So whatever fraction you divide by, you have to exclude anything that would make the numerator or the denominator 0 because it gets flipped over when you multiply by the reciprocal. So basically when you do the restrictions, the very first fraction you see, it's just anything that would make the bottom 0. The second fraction, it's going to be the top and the bottom. So you only have to do that for the second fraction. It's because it gets flipped over when you do the division. Okay, so like I said, super similar to yesterday. There's just a lot of factoring. A couple of these are just going to be some exponent properties, so a little bit of review from a couple units ago. So hopefully these are not too bad. I know some of these problems look really complicated. It's not any harder than what we worked on yesterday though. So let me look at this very first question. So I'm just going to look at the first fraction. If I am going to cancel anything out, top or bottom of either one of these, I have to put it in factored form. There's nothing we're going to do at the bottom of this. What about the top though? Do 5x and 15 have anything in common? 5. Okay, so if we pulled the 5, like out in front, I'm just going to divide both of those terms by 5, like undoing a distributive property. What would you have left? X minus 3. Yeah, you're totally right. Now, the bottom, there's nothing you can factor there. It's already a product. It's just 14 times x. Okay, now here's what I'm going to do. I'm just going to do this to save some space. I'm going to just right now, I'm going to change that to multiplication. So I'm going to change this, and I'm going to flip over that second fraction. If I'm dividing by that fraction, same thing as multiplying by the reciprocal. So all I'm going to do, I'm going to put the 7 on the top, and then as I write this, I'm just going to see if we can put this in factored form. So the top of this second fraction, when I flip it over, is going to go to the bottom. But let me just put it in factored form. Do 9 and 27 have anything in common? 9. Okay, so if I divided both of those by 9, like undid a distributive property, what would you have left? X minus 3, exactly. All right, now, this is now a problem just like yesterday. We're just multiplying straight across the top, straight across the bottom. So this is all one big fraction. If anything matches, we can cross it out, 1 on the top, 1 on the bottom. So with this, you have x minus 3, and then we just have to work with what we have left over. So the top is just 5 and 7. This is being multiplied, so I'm going to multiply 5 and 7. You got 35. The bottom, hang on, let me grab my calculator. I'm going to do 14 times 9, which is 126. And then you just have the x with the 14, so you can just write it right next to the 126. And then feel free to use your calculator. I'm just going to see if I can reduce 35 over 126. And I think I can. What is that, 5 over 18? Okay, so this would be 5 over 18. You just keep the x with the denominator. So this would be my answer. Okay, so for my restrictions, if you guys look at the original problem, what's in the denominator is 14x, so 0. Yeah, if you have a number, so not 14, but like if you have a number times x, if you have a plain x not set of parentheses, 0 is going to be the problem, because 14 times 0 would be 0. Now, on the second fraction, this one's a little weird. The original denominator is just the number 7. So there's nothing that would make that 0 because there's no variable down there. But when I flip it over, now this comes to the bottom of the fraction, so I do have a restriction there, positive 3. So just the positive 3 from the second fraction. So this would be your answer, and then your two numbers that x can't be 0 and 3. Does anybody have a question below? Okay, now this next one, I'm going to have you just write this for me real quick so it's similar to one of the homework problems, and I didn't have one like this on the notes. So we're just going to write down 12x, oh man, I just wrote this upside down, didn't I? Forgive me. Shoot. Okay, actually, I'm going to do this. Pretend that was multiplication. I'm going to flip it over in a second, but I'm going to pretend that's multiplication. I just want to show you guys the exponent properties here. You'll have one like this on the homework that you'll have to flip. Okay, now, on the top and bottom, do you guys see how I have an x minus 7? So those would go. I just want to make sure you guys know how to simplify the rest of this. So I would have 12x cubed and a y on the top. The bottom, I'm going to have a 2x and a y to the 4th. So this is really just practice with exponent properties. So can I divide 12 by 2? 6. Would it go on the top or the bottom? Perfect. Okay. Where do you have more x's, top or the bottom? How many more? 2. So this would be x squared. Basically what goes on there, that 1 in the bottom cancels out 1 in the top. All right, where do you have more y's, the top or the bottom? How many more? So this would be my answer then. Okay, now what I want to work out here with you guys really is the restrictions on this. So I did cross out that x minus 7. So 7 is a problem, positive 7. Now, a bunch of stuff canceled out, but I want you to look at the denominator here. What number, if I plugged it in for x, would cause me a problem? 0. What about y? What number would cause me a problem? Also 0. So this one's a little bit weird for my restrictions. I'm going to say x can't be 0 or 7, and then I would have separately like y can't be equal to 0. So if you have something like that where you've got a couple variables multiplied together, plugging in 0 for either of those variables would wipe out that denominator. All right, anybody have a question? Now, this next problem, I swear to you, it looks horrible, but it's not. All right, so this is just a different way to write the problem we literally just did. It's just, instead of me writing two separate fractions, I just put like a big division bar in between. So here's what this would look like. You'd have the 20x minus 5y over that x cubed y squared. And I'm going to go ahead and let me flip this over as I go. So the denominator there, the 8x cubed would go on the top when I flip it over, and then the 12x minus 3y would go on the bottom. We're just going to see if we can factor. This is a little weird because I have x and y. If you looked at that first fraction, though, do 20x and negative 5y have anything in common that you could factor out? 5. Yeah, even though the letters are different, you can take out a 5. Now, what would be left? Yep. Yep, good. 4x minus y. You can't do anything to the bottom. That's just a product, y squared and x cubed. Kind of similar with the top. This is 8x cubed. What about the bottom here? I've got 12x minus 3y. Do they have anything in common? Okay, 3. What would be left? 4x minus y. Perfect. So, once I do that, this turns into one giant fraction. And then you guys are noticing, I hope, you do have 4x minus y, 4x minus y. And actually, I have x cubed and x cubed. Now, I have a couple numbers on the top. I have 5 and 8, so I'm going to go ahead and multiply those. 5 times 8 is 40 across the top. On the bottom, I have a y squared here and a 3 here, so I got to keep both of those. Typically, you're going to put the plain number, the 3, in front, so it would look like that. And then 40 is not divisible by 3. That doesn't reduce or anything like that. So this would be my answer. Now, for my restrictions, let me go back here. So this problem right here, 0 would be a problem for x, because just 0 cubed would be 0. 0 would also be a problem for y. And then this is the one that's kind of weird. So I get this 4x minus y. What I would tell you to do, just literally say, because it's got two variables, 4x minus y, just say that can't be equal to 0, because I don't know either variable. So if it's got a couple, like I can't solve that for a number. So just take that whole thing in parentheses and say that that can't be equal to 0. So x can't be 0, y can't be 0, and then what I just wrote down, that 4x minus y, that can't be 0. That's my restrictions. All right, now everything else we're going to do today is going to be a little bit more similar to just the factoring we did yesterday. So see if you can factor these quadratics. Can you tell me two numbers that multiply to get you 8, add to get you negative 6? 4 and 2, both negative. Yep. Okay, the bottom of that fraction, can you tell me two numbers that would multiply to get you positive 4 but add to get you negative 4? Two numbers they'd multiply, it'd be positive 4. Yeah, they're actually the same. Negative 2 times negative 2 is 4. Negative 2 plus negative 2 is negative 4. Just leave it separate. You could write them squared, but let me just leave them separate for a second. Okay, now I'm going to change this division sign to multiplication. I'm just going to take that second fraction. There's nothing to factor in that at all. We're just going to flip that over. So it'll be x minus 2 and just a 1. All right, now, once I flipped it over, go ahead.
So, like, if the second one was, like, a factoring one where you factor,
Mm-hmm.
can I do that first and then switch?
Yeah, you can do however you want to do it, as long as you don't forget to flip it at some point. Now, this is one big fraction, so anybody on the top and bottom, they can cancel each other out. So I have an x minus 2 and x minus 2. They just cancel one for one. Now, I also, over here, have another x minus 2 and an x minus 2 on the bottom. So those are both one for one. They cancel out. What you would have left, you just have the x minus 4 on the top, and actually you just have a 1 on the bottom. You don't have to write the 1 if you want to just write x minus 4 as your answer. And then for my restrictions, we have 2. This would also be 2. The bottom of this fraction ends up being 1, but I had flipped that over. The restriction up here would also be, like all of these would be the same number. They're all 2. So just x can't be 2. You just have to write it one time for your restriction. All right, I'm going to try one that's got a little bit more factoring to it. All right, so this one's got a couple different types. So the top, just have a normal, like, tell me two numbers, multiply to get you negative 15, add to get you 2. They would both just start with x. If you think of two numbers, you multiply them together, negative 15, add to 2. 5 and negative 3. So one's plus 5, one's x minus 3. 5 times negative 3 is the negative 15. 5 plus negative 3 is the 2. Now, the bottom, I don't know if you guys remember this from yesterday, this is called a difference of squares. So I've got an x squared minus 16, no middle term. So if you can tell me two numbers, they would multiply to get you negative 16, but add up to 0. Negative 4 and 4. So just one of them's a plus 4, one of them's a minus 4. Doesn't matter the order. Okay, I'm just going to flip this right as I go just to save some time. So the x plus 5 is going to come down here to the bottom. And I'm just going to put parentheses around that because we're going to think about that as a factor that we're going to multiply. The bottom of this fraction, when I flip it over to do the reciprocal, is going to come to the top. So I'm going to see if I can factor that. Do 3x and 12 have anything in common? 3. All right, if you pulled a 3 out, what would be left over? X minus 4. Perfect. All right, so this whole thing is one big fraction. All right, no, anything that matches on top and bottom, we're going to cross it out one for one. So here's an x plus 5, x plus 5. X minus 4, x minus 4. Nothing else matches. So when I write my answer, I'm going to have you guys leave these in factored form. So don't multiply it out, just leave the parentheses. You have a 3 here and an x minus 3. I'm just taking that plain number and I'm going to put that in front of the parentheses, the x minus 3. And then on the bottom, I have an x plus 4. You don't need parentheses, but you can put them if you want to. This would be your answer. Okay, now for my restrictions, I'm just going to go back and write them right on here. So negative 4 would make x plus 4 0. Positive 4 would make x minus 4 0. On the second fraction, I got to do the top and the bottom. So negative 5 here, positive 4 here. I ended up with positive 4. I wrote it twice. You only have to write it once when you write your restriction. So here x can't be negative 4, positive 4, or negative 5. Those would be our problem numbers there. Okay, now let me do this. This has got a little bit of a tricky problem going on in the first fraction here, for sure. So 4x squared and 2x, right? Both of those guys have a 2 in common, but they also both have an x in common. So if I take a 2x and divide that out of both terms, left over, that first term would be 2x, and the second term would actually just be a negative 1. If I do 2x divided by 2x, it has subtraction in between there, so it would be negative 1. Okay, now the bottom is super tricky of this. I'm going to do this in 2 steps. So all these terms are divisible by 3. All these terms also have at least an x in them. And if I take that 3x out in front, this would become just 1x squared. 6 divided by 3 is 2, and I'm going to take one of the x's out, so I'd have 1 left, so it'd be minus 2x. And then 9x divided by 3x would just be minus 3. So let me just, I know if you can do this faster than that, go right ahead, but I'm going to do this in 2 steps. So I can further factor that quadratic. So that would be numbers that multiply to get you negative 3, add to get you negative 2. Yeah, there we go, negative 3. So those are the only options. You got to figure out which one's positive, which one's negative. Okay, now, this guy, we are going to end up flipping this over. I'm just going to write it down here. So the top of this fraction is x squared plus 8x plus 12. Can you think of 2 numbers that would multiply to get you 12, add to get you 8? 6 and 2. Now, here's all I'm going to do. These are going to, this is going to flip because I'm going to multiply by the reciprocal. So the x plus 6 and x plus 2 is just going to go in the bottom. And then whatever's in the bottom is going to go to the top when I flip it over. So for that one, I got to think of 2 numbers. If I multiply them, I get negative 18. Add them, I get 3. So multiply, I get negative 18. So one has to be positive, one has to be negative. Multiply, get negative 18, add to get 3. 6 and negative 3. There we go. All right. So one of them's x minus 3, one of them's x plus 6. If I multiply that, that's negative 18. If I add those, negative 3 plus 6 is 3. Now, this is one giant fraction. We're just going to see if anything matches. And let's see, x minus 3, x minus 3. X plus 6, x plus 6. And I actually, just this single x here and the single x here. Nothing else cancels. So on the top, I still had a 2. And I had, just leave this in the factored form. So just leave the parentheses. Don't actually FOIL. If you could distribute if you want to, but just leave it in that format. I think it's easier. Now on the bottom, I do have a 3. And then I have an x plus 1. And I also have an x plus 2. So this one has a little bit more left. That would be my answer. Now, my restrictions. Just the 3x, if you have a plain variable, if number in front or not, 0 is going to cause you a problem. X minus 3 would be positive 3. X plus 1 would be negative 1. Now, the second fraction, because I flipped it over, you have to do the top and the bottom. So this would be 3. This would be negative 6. This would also be negative 6. This would be negative 2. You just have to write the number one time. So one restriction was 0, one was 3, one was negative 1, one was negative 6, and I already wrote the rest of these. One was also negative 2. So those are all the different numbers that I just wrote down there. A couple of them repeated. You just have to write it once. Okay, and then do me a favor. I'm going to have you change up this very last problem here. Okay, so just cross out what was there. And my first fraction, I'm going to do 18x minus 12 over 5x. And then I'm going to divide that by 15x minus 10 over 12. This one won't be too bad, but we're going to have to do some simplifying. So what do 18x and 12 have in common? 6. All right, so I'm just going to take a 6. This would be what? 3x minus 2. Okay, now I'm going to change this. I'm going to put the 12 on the top. I'm going to flip this over. What do 15 and 10 have in common? 5. Okay, what would be left? If I took a 3x minus 2, and look at that, it's going to match. So this is all one big fraction. This is similar to one of the homework problems, which is why I wanted to do this with you guys. Okay, gone, gone. Now, what you would actually do here with what's left, you'd have to do 6 times 12, which is across the top. That'd be 72. 5 times 5 is 25. And then there was an x here. If you could reduce that, we would. I don't think that reduces, though. Let me just check. No, it does not. So this would be my answer. And then for my restrictions, 0 would be a problem here. And then if you have something like this, I would just say to yourself, just think about if you set that equal to 0, how would you get x by itself? You would add 2, and then you would divide by 3 to get x alone. So your other restriction there is going to be a fraction. So x can't be 0 or 2/3. Just 2 restrictions for that left.